What we're going to do here is sketch the first and second derivative of this function f. In order to sketch a derivative, you want to think about what a derivative means. For instance, a first derivative is the slope of the graph. So in order to sketch the first derivative, I want to look at this graph and first see where my slopes are 0, because that will help me with my first derivative graph. So can you tell at this point your slope is 0? So if my slope is 0, can I put that for my first derivative as a point of 0 there? Isn't my slope 0 at this point? So I have a slope of 0 there and a slope of 0 there. So those 3 points, I have a slope of 0. So that should help me make my first derivative. Now for my second derivative, the key point of a second derivative is points of inflections. Second derivatives are points of inflections, and points of inflections when the second derivative equals 0. So if you look at this point, that is a point of inflection. So that is where my second derivative equals 0. So for my second derivative, I'll do here in red, is this, my second derivative in red, is going to be 0 at that point. And at this point of inflection, my second derivative will be 0 as well. So I'm going to kind of outline that in red. That big dot's going to be a point of inflection. So your second derivative is red. It is 0 there at that red one, and second derivative is 0 there. So those are the key factors for when we start graphing our first and second derivative. We want to look for relative maxes and mins and points of inflections. Okay, let's graph the first derivative. So first derivative is slopes again. So at this point, left of that point, you see how we're increasing. The slopes are positive. So if my slopes are positive, what that means is my graph is going to be positive on that side. Alright, so right there, all my values are positive because the values of this green line are the slopes of this line. Now, from this point all the way down to here, can you tell you're decreasing or the slopes are all negative? So wouldn't all my slopes values be negative? So wouldn't all my values from this point to this point be negative? So to get from here to here and stay negative the whole time, I'm going to go down, okay, and have to come back. All right, so aren't all these values negative values which match negative slopes? All right, now, next, on this interval, from this green dot to this green dot, aren't they increasing? Isn't the graph increasing? The slope's positive. So if my slopes are positive, I want there to be another hump like this. All right, so I'll make another hump. All right, and then I come back around. Now, there are ways to tell how steep these humps are, but don't worry about that. When you're sketching, you don't care about how steep the humps are. The key is making the humps at the right points and the x-intercepts at the right points due to the type of derivative. This is decreasing, negative slopes. So negative slopes mean negative slope values, so those are negative values. So my graph will look like that. All that stated is this green graph is my first derivative of the function. All right, that's the first derivative. Again, increasing, positive slopes, decreasing, negative slopes, increasing, positive slopes, positive value slopes, decreasing, negative slope values. All right, and these points are where the slope is 0. Looks good. Next, our second derivative. Well, for our second derivative, we said our points of inflections are key, and we look at concavity. So for our black graph, do you see from this red dot, all right, isn't this interval concave down? So wouldn't our concavity be negative at this point? All right, so our concavity is negative, so that means we have negative value second derivatives. All right, negative values because concavity is down. From this dot to this dot, do you see how we have concave up? So it's a positive second derivatives. Concavity up is positive second derivatives. So wouldn't that be positive second derivatives be something like that? And from here to here, going on, aren't those concave down? So it would be second derivatives negative. that would be your second derivative. All right, so we did all those. Now, we got our regular function in the black, then our first derivative in the green, and our second derivative in the red. These are sketches, not exact graphs. All right. Now, one thing I want to point out, a couple of things I want to point out actually. First of all, I made a point of this, but you might not have caught on, that, do you notice if your second derivative is 0 here, wouldn't that mean the slope of this is 0? So shouldn't my point of inflection be at where the first derivative slope is 0? So your points of inflection should always have a slope of the first derivative being 0. Do you see here this point of inflection? Do you see how I have a slope of the first derivative being 0? Just be aware of that. I paid attention to that. I didn't mention it to now. But again, wherever you have a point of inflection, your first derivative slope will be 0. Because the first derivative, the derivative of the first derivative gives you the second derivative. And when the second derivative equals 0, it's points of inflections. This is where the second derivative equals 0. The slope of the first equaling 0. A lot of derivatives might confuse you a little bit, but anyways, sorry if I did. Rewind, kind of think about it, what I said again. This is important to have it as a relative max and min. All right, are very important at points of inflections for this first derivative graph. All right. Now, going back, looking at this one more time. In the black graph right here, do you understand it's a quartic graph in x to the fourth? So isn't f some sort of x to the fourth graph? So f of x is something like an x to the fourth, and it's actually a negative x to the fourth because it's upside down. Now if I derive that, I want you to think about something here. If I take derivative of this, don't you get negative 4 x to the third? Now look at this. Look at the green graph. Isn't it a negative x to the third graph? If I take the derivative of this, don't you get negative 12x squared? Isn't that a parabola? Isn't the red a parabola? Do you see how the order actually fits the graph? And x to the fourth is the black one. You derive at x to the third, which is my green, and my red is a x squared. It all kind of fits. These aren't the exact equations for the graphs, but the ideas follow even with the derivative functions. All right. Recap. When you want to sketch the first derivative, you look where the slopes are 0. Bam, bam, bam. And then you look to see where it's increasing, decreasing, to know how to draw between those dots. And on it, the relative maxes and mins will be the points of inflections, where the second derivative is 0. You want to put the second derivative equals 0, and at those points, you're going to have maxes and mins. All right. And then for the second derivative, you want to look at the concavity of the original. And where concavity is negative, it's concave down. Where concavity is positive, up, positive, and so forth. Good luck with these. They can be a little tricky for people. My students really struggle with them at some points. Just keep focusing on them. I think you can totally get them. Good luck.